Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back once again to the TV learning session program. Teacher Patrick again, I'll be with you specifically with the senior 5 class, chemistry. And we are still looking at the unit 7, which is carboxylic acids and acyl halides. So we are so far on lesson number 4. We are looking at the chemical properties of these carboxylic acids. And I hope you are ready to be with me in this session, the 30-minute session. I invite you to be with me as we go along and we look at these chemical properties. So by the end of this session, I expect you to write and explain the chemical reactions of these carboxylic acids, and I'll be expecting you to write even some of the mechanisms that we'll have looked at. So please, once again, let us be ready to go. Have your notebook and a pen so that you can put down some information, some important information. You don't need to write everything because you can't write like a machine. But at least you can put down some important information that can help you as the lesson proceeds. Before we look at the chemical properties, dear students, let us first answer one of the questions, and then we assess ourselves and find out whether we can be able to answer the question that is related with the preparation of the. So the question goes that if you wanted to convert ethanol into propanoic acid, you could do it using the flow scheme. So the flow scheme is over there. You have, this is ethanol, then reagent A, it's changed to an alkyl halide, which is bromoethane, in presence of reagent B, then it changes to ethane nitrile, then finally to propanoic acid. So for stage A, you could treat the ethanol with a mixture of red phosphorus and bromine. What reagent would you use to carry out stage B? So they have given us the answer for stage A. So we need to look at stage B. What reagent can we use? From bromoethane to ethane nitrile. So when you look at this, you see the nitrile here, this is CN, has substituted the bromine. And where do we get that cyanide ion? So we need to add potassium iodide, potassium cyanide in presence of sulfuric acid at 20 degrees Celsius. Potassium cyanide, that is part A. Write an equation for the reaction you have just given. So we need to write the equation, and we are coming from bromoethane, that is CH3, CH2, bromine, and we are adding potassium cyanide. We said this reaction takes place in the presence of concentrated sulfuric acid at 20 degrees Celsius to give to CN, propanitrile. That is the reaction C. Briefly, how do you carry out stage C? So we go to stage C. We had looked at these reactions. Do you still remember the reagents that we use? Can you put them down? Which reagent do we use? From this ether nitride to carboxylic acid, propanoic acid. So he said, write equation, briefly, how would you carry out this stage? So we need the reagent that can be used. So which reagent that can be used? We said we use water in the presence of sulfuric acid. In the presence of sulfuric acid. And do you remember the type of reaction that this is a special reaction. We gave it a name. Do you remember the name of this reaction? Well, I hope so. This is hydrolysis reaction. Hydrolysis reaction. So that was part C already. So we had part B here. This is part C. We said water in presence of an acid, which is a hydrolysis reaction. Write an equation for the reaction you have just given. Can you put down that reaction in your notebook? Just a few seconds. And then you'll have to compare the reaction that you have written down with mine and see whether you have got it right. So this is part D. The nitrile, CH3, CH2, Cn, in the presence of water and the acid, and then even heat forms CH3, CH2, and H2. You remember we said this reaction goes through an amide. It doesn't go straight, but eventually, so further hydrolysis of the amide will eventually give the carboxylic acid. CH2, COOH. CH2. So that is the reaction. The right equation for the reaction you have just stated in C. So that is part D. Name the compound. So the compound over here, CH3, CH2, Cn. That is part A. Propane nitrile. Propane nitrile. That is the name. This belongs to the family of organic compounds called nitriles or cyanohydrins They are generally called cyanohydrins or nitriles. So that is the family of those compounds that have the functional group of Cn. So let us proceed and look at the reactions of the carboxylic acids. So there are different types of the reactions. So the reactions are categorized into three parts. The reaction involving hydrogen of the hydroxyl group, and the reaction involving OH of the carboxylic group. So those ones are referred to as nucleophilic substitution reactions. This is what I'm talking about. If you have a carboxylic acid, this is a carboxylic acid. So we have reactions whereby the reaction is only occurring, whatever substance is reacting is only reacting with the hydrogen gas over here. That is the reaction involving the hydrogen. Then we have reactions whereby the whole of this OH group will be involved. And then we have the reactions that involves the carbonyl group. So those are three categories of the reactions. The first category of the reaction is whereby you have the hydrogen involved. The second category is where you have the OH involved. And then the third category, you have the carbonyl group also involved. So in the first category, if you're talking about the first category, that involves the hydrogen atom there, those are reactions of carboxylic acids as acids. As acids. As acids. For example, look at that. When carboxylic acids react with metals. So in this case, this carboxylic acid is behaving as an acid, like other mineral acids. So if you have ethanoic acid combining with sodium metal and forming sodium ethanoate plus the hydrogen gas. So when you look at this reaction, you see that the sodium is substituting this hydrogen, so it is displacing it from the acid. So the hydrogen is displaced. This is an acid, this is a metal, this is a salt, and this is hydrogen gas. So this reaction can be compared, just name any mineral acid. Sulfuric acid, nitric acid, hydrochloric acid. Let's use sulfuric acid. When it reacts with metals, that is either sodium, so the sodium here will displace the hydrogen atoms here, and then you'll get sodium sulfate plus the hydrogen gas. This is the hydrogen, this is the salt, the metal, and the acid. So in this case, this ethanoic acid is behaving like other acids. All acids react with metals to liberate hydrogen gas. That is, they form salt and the hydrogen gas. You can use any other metal, not necessarily sodium. Let's use ethanoic acid and magnesium. So this one will give magnesium ethanoate. Magnesium ethanoate plus the hydrogen gas. Magnesium ethanoate plus hydrogen gas. So it applies to all acids when they react with metals. So another reaction under that category is the reaction with alkalis. As you know, all acids react with alkalis or bases to form salt and water. I hope you remember the type of reaction. Do you still remember that type of reaction? Does everybody remember that type of reaction? I hope so. You still remember. That is a neutralization reaction. When you have an acid, so in this case, we are using ethanoic acid. When we use ethanoic acid, it is representing all other acids. So they will be behaving similarly. So we are using ethanoic acid reacting with sodium hydroxide. This will give sodium ethanoate and water. This is a salt. This is water. This is a base. And this is an acid. Acid plus bases, you get salt and water. This is a neutralization reaction. Think of any other mineral acid. We used sulfuric acid. Let's use another mineral acid. Maybe hydrochloric acid. If we use hydrochloric acid as an example, hydrochloric acid reacting with sodium hydroxide. This is sodium chloride plus water. This is the same. The reaction is similar. Acids and bases So in this case, carboxylic acid, which is an organic acid, is behaving like other mineral acids. Looking at other reactions under the same category, we can mention the reaction with carbonates and hydrogen carbonates. You know, when carbonates and hydrogen carbonates react, they will produce, with acids, they will produce the salt, carbon dioxide, and water. So when you have an acid plus a carbonate, you get the salt plus carbon dioxide plus water. So in this case, if we are using sulfuric acid, or rather if we are using ethanoic acid, it is behaving in the same way. Ethanoic acid with any carbonate, just mention any carbonate, maybe sodium carbonate. Let's use sodium carbonate. This will give sodium ethanoate. This is the salt plus carbon dioxide and water. So this reaction, in this case, this carboxylic acid is behaving like other acids. Similarly, if you have hydrochloric acid and it is reacting with the same carbonate, you will get sodium carbonate, that is the salt, plus carbon dioxide, plus water. The salt. So hydrogen carbonates behave in the same way. If you have any hydrogen carbonate, it will behave in the same way. For example, if you have, this is ethanoic acid plus sodium hydrogen carbonate. So this will produce the same salt, carbon dioxide, and water. So it produces sodium ethanoate plus carbon dioxide and water. So they are the same reactions. So in this case, these carboxylic acids are behaving like other mineral acids. Those are some of the reactions that we talked about. The first category, where the hydrogen is the only one that is involved. Did you take note of that? Please, take note of that one. When you look at this, hydrogen is displacing here. The hydrogen gas is only the atom in the carboxylic acid that is being involved. So we can just go to the second category where we have the OH group is involved. So reaction with alcohols, we had looked at this reaction when we looked at the alcohols. The same reaction is coming. Actually, that is why organic chemistry, that's what makes organic chemistry more simpler. Because as you are studying these families, some of the reactions are being repeated. And these families are very close related. So you'll find that reactions getting repeated, and you'll have any problem with the reactions. So when an alcohol reacting with the carboxylic acid, this will produce an ester and water. We had even looked at these reactions of forming the esters and water. You can use a simple reaction. You have CH3, CH2OH, that is an alcohol, plus any other carboxylic acid, using this reaction is reversible, and remember it takes place at the conditions. Sulfuric acid at 100 degrees Celsius. So it will form the ester, CH2, CH3 plus water. This is the ester that is formed. ethyl ethanoate. Ethyl ethanoate. That is the reaction. That reaction is involving the whole of the OH group. When you look at this what the oxygen here combining with this one, and then they remove the water molecule. So the reaction is taking place on the OH. So for the mechanism, because we had done this mechanism even before when we were looking at the alcohols, so I will not keep repeating, but that is the mechanism. The same mechanism, if you can still recall. And we went through each step, and I was able to explain step by step. So it is the same mechanism, as I mentioned, that we had looked at this. So the reaction with phosphorus halides, even the same reaction, we said carboxylic acid, the alcohols also react with these carboxylic acids. They react with the carboxylic acids to produce acyl halides and other compounds. So those are some of the reactions. Maybe I can just do one example, one mechanism for the carboxylic acid, where it is reacting with the thionyl chloride. This is chlorine. That is thionyl chloride. So you have this molecule there moving, and then this one coming over there. This one is moving. So this one is coming. This arrow is moving, so one arrow gets broken. So you have CH3, COH. You have oxygen with the sulfur. That is oxygen minus one chlorine. There is one, this chlorine has moved away. So you still have one chlorine over there. So this one, when this one moves out, you will have this one coming back. So you have, this is the bond over here. So you have this one coming back to neutralize that. And eventually this one moves, breaks, and this one neutralizes this. So you have CH3C with oxygen, that is the double bond, this plus the sulfur dioxide plus the chloride. So that chloride now comes, and then you have CH3 with chlorine plus the sulfur chloride plus, that is sulfur dioxide, and then you have the hydrogen here, which will form the hydrogen chloride. So that is the final, which is the thionyl chloride. That is one of the mechanisms. We did even the mechanism even before when we were looking at the alcohols. Then the last one is the reaction that involves this. Because we have said there are three categories. Reactions involving hydrogen, reaction involving OH, and the reactions involving this carbonyl group. So that is the reduction reactions. Carboxylic acids are reduced to alcohols, or they are reduced to alcohols, or carbonyl compounds, depending on the type of the carboxylic acid and the reagent, the reducing agent that can be used. Hydrogen, in presence of hydrogen and nickel, these are strong reducing agents. So the carboxylic acids will be reduced to primary alcohols. So if you have a carboxylic acid, if it is a primary alcohol, carboxylic acid, CH2, this is propanoic acid. In presence of any reducing agent, it can be nickel, in presence of that is a catalyst, reacting with hydrogen, so the reducing agent is hydrogen. So this one will give propanol. It will reduce it to propanol. That is the same with the lithium aluminum hydride in presence of the ether, then it can also change into the primary alcohol. So instead of using nickel and hydrogen, you can as well use lithium aluminum hydride, that is lithium aluminum hydride in presence of ether, or you can use lithium sodium, can use lithium borohydride. Lithium borohydride, even this one can also be, or sodium borohydride, or sodium borohydride, also in presence of ether. These are other reducing agents that can be used. So let's look at some of the uses of the carboxylic acid. Food additives, benzoic acid as a preservative in the food, in foods for preservation. Vinegar in ingredients as acetic acid, that is common, that is used to dress salads. Lactic acid in the manufacture of the milk products like cheese and yogurt. Then analgesics and or the painkillers. One of them is aspirin. All those are manufactured using these carboxylic acids. Some synthetic drugs, similarly to those, the painkillers, and then some of the fungicides, and even vitamin C as a medicine. Vitamin C as a medicine, which is ascorbic acid, is a carboxylic acid. Some laxatives. So there's some of the drugs that may help in the digestion of the food. Those are the laxatives. Varnishes and transparent adhesives. Then the paints and varnishes for the wood, because we are giving those examples, the shampoos, the detergents. So carboxylic acids are actually very, very important. And paraffin or paraffin candle waxes and rubber. So before I leave, I would like to leave some simple homework over there. Please capture the homework and try to answer those questions and see whether you've been following. If you are not able, then that means you need to go and revise a bit. Thank you so much for being with me in these 30 minutes. I hope to see you in the next session. Bye-bye.